Okay, hello everyone. My name is Max, and for the past almost 2 years I've been working here at Juno in Minsk. And today I'm going to talk about code generation in Go regarding to tests. And I was told that I shouldn't pronounce any F words, so it will be really short presentation. So why do we generate code for testing? The thing is that according to my observations, it's only about 10% of code that we write is actual business logic. It's the interesting part, right? And all the rest is either tests or some testing helpers like mocks and so on. And as Mike was telling you in his presentation, typically to write testable code, you have to define your dependencies via the interfaces, just in order to be able to mock it, to swap it with some local implementation of the dependency. And then you have to write your tests and mock your dependencies, and finally run your test and see the result. And let's start from defining interfaces for the dependencies. Typically, when you're integrating with some third-party service or a package, you have a struct. And there are a few public methods on the struct that represent an API of this package or third-party service. And while I was preparing to this presentation, I actually made different slide, and it was about iFace Maker tool that scans a Go file with in order to find a struct that you points to and its public methods, and extract those public methods to an interface. Of course, in this very case, it's probably easier just like to copy signature of the call method to some interface and create it yourself. But for example, when you have rich APIs with dozens of methods, it's where it becomes boring, right? Because you have to copy all this signature of all these methods, and there can be a lot. So I ended up, like 2 days ago when I was preparing, ended up writing my own tool, because iFace Maker simply has too many issues with edge cases, and it simply doesn't work for me even for this presentation. So what this typeface tool does is that it does basically the same. So it scans a Go file or a package. It understands packages, so you can, for example, generate an interface from some standard library package. So it scans this, it inspects the structure and extract its public method to an interface. And then you can use this interface as a dependency in your code. Another nice tool that I and some of my colleagues use is the Go tests. And what this tool does is that it generates for you a table test. Who knows what table tests are? Okay. So it generates for you a table test, so you don't have to write it yourself. And there are plugins for popular editors like Vim, Emacs, Atom, Sublime, and so on. It's a really nice tool. I highly recommend to use it. Another big issue about testing is mocking your dependencies, and there are few tools that can help you with that. And the most popular ones are Mockery, Golang Mock, and Counterfeiter. Unfortunately, none of these tools actually suit our needs. And here's why. Like, for example, mockery heavily relies on reflection, and also it has like really weird way to mock dependencies by passing a function name that you want to mock as a string, and it's really easy to imagine what happens when you change the signature or the name of the function. Your test will still compile, but you'll get lots of errors from the tests. And in such cases, I would prefer just to see a compilation errors that we used to see when we are compiling our Go programs. Another tool is GoLangMock, and there is the same story here. It relies on reflection, and it doesn't work with embedded interfaces. Like, for example, in standard library, you can find reader-writer interface, which basically embeds reader and writer interfaces. So it doesn't work for such interfaces. And it also takes an arguments as the empty interface type. So you actually can pass everything here. See, I'm mocking the string method, and as return value, I can pass a number. And this is also a problem. There is another tool, counterfeiter, and it's much better tool because it doesn't rely on reflection, but it's not integrated with standard testing package, and it lacks some functionality. So what I wanted to tell you is that our tests are actually Go programs. When you run Go tests, you actually compile your test, and only then it's being executed. So if you have some problems with types and function signatures, I would prefer just to see compiler errors in such case, instead of going through the hundreds of failed tests, right? So we actually don't write Go programs like this. We don't refer to our functions via the strings. We don't pass an empty interface everywhere as a parameter. So I finally ended up writing this tool that called Minimock. And the main features of the Minimock is that it's integrated with a standard Go testing package. It implements a builder pattern. It provides few helpers that can help to write your tests. And it generates concurrent safe mock execution counters. So here's an example for the stringer interface that looks like this and defined in fun package. You'll get the mock structure generated for you that looks like this. And the Minimock actually exploits the idea of first-class functions in Go. So it generates for you a structure with a string func property. And the type of this property is actually a func with the same signature as in original interface. It also generates an execution counter and a proxy structure to write to initialize your mocks via the builder pattern. And here's how generated string implementation looks like. So we can see that it increments a counter atomically and checks that if you mock the function, if you actually didn't mock the function, it will stop the test with an error. Or if you did, then it basically runs the string func. There are several ways to set up a mocks with Minimock. One of the simplest ways is just by doing direct assignment. So here you can see that we initialize the mock, and we basically assign a closure to the string func property. And in this case, our string func string mock will return mini-mock string. Another way to set up a mock is by using builder pattern. So here we're actually setting up the very same mock, just differently. So you can see we are calling for return and pass mini-mock. And mini-mock argument here is actually a string. So it corresponds the result parameter of the string method of the stringer interface that we are mocking. Another way is to set up a mock using builder and set helper. Same here, same helper. We just pass this function via the set method. And what actually builder pattern allows us to do is to chain a mock initialization of the different methods of an interface. So imagine we have this kind of stupid interface with like string and int methods. And we can set up all mocks for this method via the one-liner. So you can see it here. We mocked two functions here. We mocked string function and int function. And notice also that we take parameters according to their types. So if you messed with type somewhere, actually compiler will give you an error. There is also a finish helper that verifies that all your mocks that you set up during the tests have been actually called. And why is it important is that because over time in the tested code, you can stop using some dependency. And in the test, you still initialize this dependency. So you can face the situation when, while your code, the tested code, can shrink, your tests are only growing. And you don't understand what mocks are you actually using and what is just garbage here. So this is a very important function, and you probably noticed that I was using it almost everywhere, right? And another little helper is the wait, and it helps you to test concurrent code. When you're using your dependency in the Go routine, it's actually forces you to write kind of complicated tests. You're starting to use channels in your mocks and then synchronizing these channels. And instead, you can just use this wait method. And what it does is that in the worst scenario, it will pause your test up to a second. But it will check that during your test, you actually call the string. So here is when my presentation stops, and we are continuing with the coding session. So with all that said, let's implement our first test. Okay, let's say we have a service here. So you can see that it's a very simple service, let's call it service. And it has a locate handler which takes an address and returns us a GPS location of this address. And how it works is that it first tries to find this address in the local storage, in the local cache. And if there is something found, which just basically returns a location from our local storage. And if not, we are calling for a third-party system and trying to find this location. Then we return this location to the client. And meanwhile, concurrently, we are storing location in the cache. So for future requests, we can just find it in our storage. And our client doesn't have to wait for the storage when we put this location in the storage, right? Because we're using Go routines. So here you can see that our dependency is defined via the concrete structures. So this client is structure, and the locator client is also structure. It's very typical situation. So first of all, we have to replace these structures with the interfaces. And here where typeface tool can help you. So we are going to the terminal and just looking how we can generate an interface for the storage client, for example. And basically, we just need to point it to the right file and the right output file. We are generating the interface for the client, struct, package main, and that's probably it, right? Nope. So okay, the interface name. Let it be storage. So now we have the storage interface generated for us. We can see that there are two methods that we can find in the storage client. And it also generates us an example of minimock command to generate the mock. So let's generate a mock. And now we generated a mock for our storage. So you can see that it has functions that can be mocked. And let's repeat the same procedure for the locator service. Let's just change the packages. And the output file name. And the interface name. And let's generate a mock. So now we have interfaces and mock generated. And if we replace our concrete structures that we depend on with the interfaces that we just generated, we are basically ready to test our code, right? So remember I was telling you about GoTest tool that generate table tests for you. And what I'm going to do is just like to press magic buttons in Vim, magic shortcut, and you can see that there is test generated for the locate method. And here's how it looks. So this code was automatically generated. And now we simply have to replace our dependencies with the mocks, because we are going to use not only interfaces names, not only methods of an interface, but also helpers from the minimock itself. So we are going to replace it with storage mock and locator mock. And now we can write our first test. And the name of this test will be get from storage failed. By the way, are there any guys who use BDD daily? Oh man, you went to the wrong place. Okay, so let's mock our storage. Notice that I'm passing t struct to the storage. And we have to mock the first method, get. So we are going to use get mock proxy structure and set a function here. So we passing an address as a string and get storage point and an error. And here we have to check that the address that was passed from our client to the service like eighth method is actually matches the address that we putting to our storage, to the query to our storage. So we have to make an assertion here. And okay, I forgot to add the parameter here. So as we know, in every Soviet city there is Lenin Street, so you can go wrong with it. Okay, and we have to check that we passed a very same address to the call to the storage. Okay, I think we are basically ready to run our test. Let's see if it works. Doesn't. It's a live coding session, guys, so there should be problems. Yeah. Can't figure out what's the problem here. Let's just try to swap it with require. Also doesn't work. Okay. So actually DB failed. So let's try it now. Okay, the test actually worked, but I forgot to specify the expectations. So you can see that in our service, if our storage failed, then we need to return an error. So we actually expect an error from this test, right? So we have to say that we expect it. And now our test passed. So here's one thing that we should do when we use minimock is that we have to call for the either finish method or a wait method. So let's put it in our code, and let's check that at the end of this test run, we are going to execute finish or wait. So if we mocked our storage, then we're going to call for finish method. Let's run our test again. So what it means is that we actually verify that during the test, this get method of the storage was called. And now we can continue and fill our table with other tests. So let's look at our service, and we see that if it actually returned not found error, then we continuing to then we request to the locator service, and let's fill our test accordingly. So let's run this and actually return something from storage. So now we don't expect an error, so we can remove this, but we expect the results from our locate method, and they should match the coordinates that are stored in the storage point, right? So we want 1 as the first return argument, and we want 2 as the second one. And let's just check that everything works. Oops. Yes. Okay. Test works, and we can continue with our next test case. Let's say storage returned not found error, and the locator also failed during the execution. So let's emulate this situation. So storage returned new, and storage are not found error. And now we have to mock our locator service. So we are introducing new mock to the dependencies. So we are mocking a find method via the set. Okay. And now we have to check that the address we passed to locator is the same as was passed to the function that we are actually testing, right? So And we again expect an error here. And also we need to make sure that we call to the finish method of the locator. Okay, let's try if we find here. No. Line 58. Oh yes, I forgot to put the type of the argument. Okay, let's do it again. And the test is passed. So let's continue and cover the whole locate method, right? So we have actually the last case, the successful case, where locator actually returned us something. So we are going to copy the previous test case and put it in our table again. And the locator is actually succeed. And returned no error. So in this case, we don't expect any errors, but we expect the same position that was returned by our locator. So we want 3 as the first return parameter, and we want 4 as the second one. And here's the thing, that we are actually, in this case, we are actually calling for the put method of the storage, and we do it in the Go routine. So instead of using finish for the storage mock, we have to use wait. And in the worst case scenario, we are going to wait for 1 second. And we also have to mock the put method. So we are going back to our test and mocking also a put method. And here we use builder pattern. So we defining put mock. And this func accepts an address again, and the storage point. And it returns nil. Okay. And let's run our test again. And the test is passed. So we actually covered this locator method with a test. And almost everything for this test was generated automatically. And let's just look at the numbers. So initially, we had only service Go file here, which is which is 30 lines long, right? And let's count how much did we generate to enable to be able to test this method. So let's cat for locator, storage, and that's basically it. So 11 times more code was generated to write this test. And the test itself is 3 times larger than the actual tested code. So my point is tests are very expensive. And while writing our programs, we just almost forced to use some generation tools. And my idea is just go find the tools that you need, and maybe you'll find these tools that I was talking about useful. And that's basically it. So maybe you have any questions?
Hi, thanks for your presentation. I have a couple of questions for you. First of all, in your live coding sessions, you were implementing those table tests.
Yes.
So, and those table tests looks a little bit, so they actually are quite big. I mean, the test itself.
Yes.
So, do you think it's it's a place where we need to use stable tests actually? Maybe it would be better to use just a simple tests, combine them in a suite, and then if we do it, we will be able to use this Go test. We can check, we can choose which particular test we can run now.
Well, the thing about table tests is that it's really easy to add new cases. And for example, when you're dealing with some bug, it's really easy to just like introduce new test case when you have a table test. Of course, it's not, I mean, you don't have to use it in every situation, but since this code is generated, and basically what I have to do is just like to fill one case. For example, if I want to just like test, for example, positive scenario, I'll end with table test anyway, just because I know that maybe in the future I will add more test cases and it will be just like easier for me. But we also write normal tests with like a couple of cases in one test function.
Okay, thanks. The second question is, actually we are using GoMock, and first question about your own packages. Is there any way to check params which will be passed to this mocked interface in a single liner without providing callback?
It is a good idea. Not yet. Maybe I'll add it in the future. But my idea is that, well, it's better. Probably it's better to return to the code. Oops. Okay, let's look at the test again. So my idea is that the way it's done in GoMock is kind of making you think like upside down a little bit. Because like you define the expectation before you run the test. And my idea is that it's better to actually check the parameters in the functions. So it actually like makes your test more readable. I agree that you have to, I mean, with GoMock you can do it easier, but I don't think it makes it more readable. But it's a great question, and I think I'll add this functionality like soon to the Minimock.
Sorry for bothering you. Actually, two more questions. One question is about this finalize or done.
Yes, yes.
So actually here we need to call this final finish method for both. Why can't we just implement something like a controller in GoMock?
Yes. Yeah, in GoMock you call this finish method on a controller. Here you have to call it for every dependency. That's the difference. So, and it probably won't be changed.
Okay, and the final question is, you said that you have this wait method
Yes.
And you said that you can use it for testing concurrently, something which is concurrent or something like that. Do you think it's suitable, so unit tests are actually suitable for concurrent testing? Actually, you can place, you can use any timeout, 10 seconds, minutes, hours, yes. But if you, for example, you end if you run out of memory, you can actually wait forever, and it makes your tests, your unit tests, really slow. So,
yes, it's. I mean, there are actually like two questions. First, like, should we test concurrent code? And the answer is yes, because we can. I just shown you how you can do it, right? So it's testable. You can do it. Another question is that what timeout to put in the wait method, and this is just up to you. Like, I just want to mention that it's the worst case scenario. Like when you write test, you expect something to be called, and it haven't been called. So in this situation, you'll wait for your test to run 1 second, and it will produce you an output that it was expecting something, and this dependency haven't been used, and your test is failed. So.
Okay, thanks.
Okay. Thank you for your presentation. I have a function. I saw a function like wait, and we check if any Go routines takes longer than we need. And the question how your function wait stops the Go routine or kill if there are any in the test.
You might notice that. Let's go back to the test. Okay, so here we're actually running our test via the trun, and this is the function, right?
Yep.
And we are making a deferred call to the wait method. So when the test case is complete, it actually will wait while wait ends. And the wait, since it's integrated with testing T package, just calls for a fail now method of the testing T. And that's how your test is failed. So once you exit of the wait method, the testing magic kind of understands that test has failed.
So all tests stop after the...
Only one test. Only one test with the message that it expected call to something, and this something haven't been used.
Okay, thanks.
Hi, great presentation, thank you. I don't miss generics in Go, but let's say I did. Can we use code generation? Do you think this is a good tool to implement generics?
Yes, we generate tons of code, actually. And I personally never faced the situation when I need generics. And I came from the Ruby background. And I don't know, it wasn't painful for me. Like some things, when you discover some pattern that you repeat again and again and again, and you can automate it via the helper, so like some helping code. This is the place where you probably have to generate the code. And that's what we do. We just discover these patterns and write our tools that help us to automate this stuff. Okay.
More questions?
Any more questions?
Okay, looks like not. Thanks, Max.
You.